Hello everyone and welcome to another video. Yesterday I basically spent more than 2 hours banging my head against the C preprocessor and I was only able to achieve half of what I wanted. So today's episode is going to be a little bit shorter. I don't really feel like spending another 2 hours around some problem I don't even know if it is possible to fix in C. So I'm just going to change the implementation of the pool allocator, and we're basically going to fix this comment, and I think that's going to be already a good episode. All right, so the first thing I want to do is to have multiple block sizes, right? So we can have something like a pool block of, I don't know, 64 bytes, for example. And here I don't want to use a list, I want to use a bucket list, and here I'm going to say just that, and I'm going to say bucket list. Well, I can remove that, to be honest. Okay, so this is a 64 byte block. This is going to be block underscore 64 bytes. Capacity is just going to be 64 divided by that. Then we probably want a slightly larger block. So this is going to be for small objects, right? So we can allocate small objects. Usually structs that are allocated, I don't intend to go further than 64 bytes because I'm going to use Raylib, and most structures in Raylib are smaller than 64 bytes, so I think that's just fine. So here I can say blocks 64 bytes, or whatever. So I probably should just add this here, like so. And here I'm going to use a bucket list. Okay, then I need another structure. I'm thinking about what should I use for medium-size allocations. We can change these values in the future, obviously. Well, actually, let me just make this a little bit better. So I can just say 64B. So I can use KB for the kilobytes. This is it. So this is going to be 64 bytes, and this is going to be 64 bytes, and this is just going to be 64B. Alright, here I can probably say, I don't know, for now I may just use 4 kilobytes. Maybe this is too much. Probably this is too much. I can use like 1 kilobyte or something. And here I can define the capacity for 1 kilobyte. This is going to be 1024 bytes divided by the size of a word. And then I may also want, for now, just for very large allocations, I may want, I don't know, something like 64K, 64 kilobytes. I think that's good. So this is probably just going to be for network buffers and stuff like that, because I'm going to use libuv, and the suggested allocation size that libuv generally requests is 64 kilobytes. So that's why I'm specifically doing this, right? So 64 times 1024, that's it, and this needs to be used here, and we no longer need this flag because we are using bucket lists, right? So we no longer need this flag, and yeah, we can simply now have multiple fields, kilobytes, and oh, I actually need to do this. So this is going to be here, and this is going to be 1 kilobytes, and here is like so. And then we need another one for the 64 kilobyte buckets, like this. Looks 64 KB. And in the future, if we really need it, we can add then a bucket list for like blocks that are larger than 64, but in those cases the block is going to be like a region that is going to contain its own capacity, right? So it's not going to be a fixed size capacity, the capacity is going to be variable. But for now I think that these 3 different block sizes are more than enough for my purpose in this case. And this is for small blocks, this is like for requests and responses, and this is for like buffers that I'm going to use to send data through the network, basically. Okay, so yeah, I think we can go here. Here I don't need to change anything, I believe. And now when we say pull alloc, we need to have some, actually I can, whatever, I can say something like if size bytes is less than 64, so if we try to allocate less than 64 bytes, then if we try to allocate less than 1 kilobyte, and then if we try to allocate less than actually this is less or equal, right? Because we can actually allocate that range. In this case it's going to be 64 times 1024. I probably can use a macro, so I can say define kb of x is equal to x times 1024, and here I can simply say kb1 and here kb 64, right? And with that I can also change this to be kb1 and here kb64. Okay, so now if I need less than 64, I am going to need to do buckets list add, and I'm going to add to my full dot 64 bytes, and the element is going to be, well, actually I need to traverse, yeah, exactly. So I need to say buckets list for each, right? And this is going to be my bucket list. I need to pass it by pointer. And now basically what do I need to do? I need to say so this is going to traverse, and the pointer to this is going to be, where is it? It's going to be data, right? It's going to be data, but I need but if I do add, yeah, I think that's going to work. Well, I probably want another operation, or do I? Because adds an element, that's fine. And if this doesn't exist, it just appends another one. But I may just want to get, so this is the same problem we were facing last episodes, right? Because sometimes I don't want to add a specific element, I may just want to like get an element, right? So I probably can just say, we can call it get for now, and this is going to be element pointer or something. Let's be explicit. And instead of doing this, we are actually going to say that the element pointer, right, is going to contain a reference to the specific slot, right? So this is going to contain a reference to this specific slot, but in that case this actually needs to be a pointer to a pointer, right? Because we need to change the value pointed by a pointer. Yes, so this needs to be a pointer to a pointer, and that should work. So we can say PTR to PTR or something. Yeah, just to be a little bit more explicit on what we are trying to tell the user. And so this just needs to be the same thing. So this is going to point at this specific slot, right? That is going to point at this specific slot. So that's everything. Yes, and here I can simply implement bucket list add in terms of this, right? But let's just focus on what we are trying to implement. It is the pull, but so yeah. So here I can simply say bucket list get, and I pass the bucket list. I pass them the bucket list, and here I need to pass a pointer to the data, and in this case it's going to be a uint pointer data, right? And I just need to pass a pointer to here. Did I use parentheses? Let me check. Where is it? It's here. So I did not use parentheses. I should actually use parentheses here, right? Well, but since this is a macro, this is inside the same scope, and if it is inside the same scope, I can simply say element pointer. I don't really need to pass a pointer to a pointer because this is not a function. So yeah, since this is not a function, all of that is correct, I believe, right? Yeah, everything should be correct because it is simply not a function. So I can just say this, in theory. Let me say pointer to pointer is undefined. I've probably forgot to change the name of it. Yes, so I can say this is my pointer, this is my pointer. Okay, and so I got the pointer to my data, and now this data field points to the allocated data inside a free slot, right? And this macro already sets the slot to be occupied, correct? Yes. So this is exactly the behavior you want, and now I can simply return data, right? So I don't really need to do anything else. And we can just do the same thing for all of these special cases. So here is going to be 1K, and here is going to be 64 KB, right? And this should already work. And else we can simply assert for now, and we can say 0 and not implemented yet. Okay, and we no longer need any of this. Okay, So now this pool allocator contains multiple sized blocks, right? So we have 64 bytes, 1 kilobyte, and 64 kilobytes. So we can have less waste on our allocations. And in the future, if that's required, we can simply add an last fallback where we just support anything above 64 KB, right? And that should be fine. Okay, so now I can, so this, yeah, because blocks is now a bucket list, so we probably should change this demo. So make pool is correct, pool alloc, right? So do I want to do this manually? Well, we can keep doing this manually. So I can just say list bucket list for each, right? And this is going to need to be block 64, and I can say blocks 64 count, right? So this can be like this, and I need to do a similar thing for the 1 KB, and this is actually a B. This is 1 KB, and this is blocks 1 KB, and another one for the 64 KB. In the future, we are going to store these metrics inside the bucket list struct, but yeah, I'm still not really sure what kind of metrics are going to be useful to the user, so we're going to do this manually right now. After alloc3 ints, we have, and now we need to say that amount of blocks and another amount of that blocks and another amount of these blocks. Okay, in here we can just say this, and I can probably change the line, and we can say that, and finally that. Okay, so we just need to copy this code, actually all of it, and this behavior is actually going to be a little bit better because yeah, I can say this, and I don't need this size t anymore. So after, I can just copy this. Okay, and finally we copy once again all of that, we paste it here, and we copy this. Okay, and we can discard that. So yeah, let's see how this pool allocator behaves now. We can compile and run. Okay, so oh, okay, well, oh, I see. Do I see? So this slot's 0. Why is it complaining? I don't really understand. So block 64 KB. Oh, I know. Okay, because yeah, my element in my list pool, bucket list get, well, my slot is going to contain the bucket itself. Yeah, that's correct. So this is actually a block 64b, and this is my block. Yeah, so that's correct. And here we need to return block.data actually. Yes, that's actually correct. I had a mistake here, so we can say block data, and then block and then block data. These should compile now, I believe. Let's see. Yes, it does compile. So this is the bucket list demo, but I want the pull allocator demo. Where is it? It's not printing anything. Pull allocator demo. Did it crash? It probably just crashed. Right, so if I don't do this, is it going to print anything? Yes, it did. So this is crashing after pull alloc. But why is that? So I have something wrong with my bucket list kit. Right, I have something wrong with my bucket list kit. So it is very weird. I don't know why this is crashing. Why are you crashing? So let me just add a printf just to be able to debug. I think it's somewhere here, probably. Let's see. Okay, so it's not crashing there. What? Are you crashing somewhere else? So can I print something in here? I cannot. Why is it? What is going on? Am I getting even inside here? I am not. So what's going on? So am I stupid? I don't know. Let me just return null for now. Something very strange is happening and I don't really understand what is it. So this works, right? This works. Okay, so let me actually move this here and let me enable some of this stuff. Let me remove this else. Maybe it's reaching that. Alright, so it's crashing now. Why are you crashing? What is going on? Are you even getting inside here? So if I don't do that, do you crash? Set but not used. Let me avoid it. Yes, you do crash. So it's something with this macro, right? If I don't do this, it still crashes. What? How can you crash? Is it this stuff? What? I'm so confused. Is it entering something else? It shouldn't, really. This is correct, right? So X, yeah. So let me say 1. Let me say 2. And what is going on? It's not just, it just simply refuses to do stuff. Okay. what is going on. So it did reach here. So something is crashing the program, right? Is it my thing here? So this worked. Does this work? Yes, okay. So that worked. And it did in fact allocate one block in my bucket list, right? One bucket actually, and one bucket has 64 blocks. Are you complaining about that? No. So do you complain about this? Do you complain about this? No. Okay, so you are complaining about this, right? Maybe I'm allocating too much memory. Yeah, it crashes here. I'm using the correct variable. So that's strange. So that's working and that's working. But what kind of allocation requires 64? So 1000 integers need, oh yeah, this needs that. Is it this that's causing the problem? I'm probably allocating too much stuff. Yeah, so 64 kilobytes times 64, how many is that? Let me make some calculations. So 64 times 64, and that's the number of megabytes. So okay, so that's 4 gigabytes, right? So that's 4 gigabytes. Yep. No, that's the amount of megabyte. Yeah, kilo, mega, giga. So let me just make sure. So 64 times 1024, that's the size of a single block, and we need 64 blocks. Yep, that's 4 gigabytes, and it is crashing when it tries to allocate 4 gigabytes at once. Okay, but it should work, right? So it shouldn't really complain. It's still too much, I know that, right? It's still too much, but it shouldn't really crash. But this is probably caused my malloc. If I had to bet, I would say, yeah, this is malloc stuff. So we need to change actually the pool allocator implementation a little bit, because we cannot use a bucket list for the 64 kilobyte blocks, I think, because we are allocating 4 gigabytes every time we need a single 64 kilobyte blocks, because we are allocating like 64 at once, right? So to be cheaper. So it's fine to allocate here 64 kilobytes at once, but this is probably too much, right? This is probably too much. So for this specific case, I think actually that the list is the best. I think that the list of this is actually better. So we only allocate one block at once. So yeah, okay, so that. And this is probably better, I would say. So let me do this. And this is going to now need implementation. I can change the name later. This is just to test the code, right? So we always refactor the code afterwards and we improve it. But here we're going to have get, and this is going to be element ptr, and we just need to say this, right? So this is equal to that, the pointer to node data. And we have that. And here I can just say list gets. I'm going to change this name later. It doesn't really mean anything to me right now. So I probably need to change it later, but whatever. So we have the list cat, and we just get a single block instead of 64 blocks at once, right? So this pool allocator is already using different data structures depending the size of the data. Because yeah, it doesn't really make sense to allocate 64 kilobyte blocks at once. That's 4 gigabytes, and it's probably going to be very expensive, right? But it does make sense to allocate this at once, right? So 64 bytes times 64 is very cheap. Let me see. Yeah, I already have this open, so that's the amount of kilobytes. So just 4 kilobytes at once, and this is just 64 kilobytes at once, and this was the one that was causing problems because it was too much. So I expect this to work now. Actually, I need to fix stuff first. So, oh yeah, here I no longer use this. I actually use list for each. One of the benefits of having generic macros, the one that I hoped I could program yesterday, but I was not able to, is that we would not need to change the macro itself. This would work with any data structure, but we will find a way in the future to have that working, I'm sure. Okay, so yeah, this now works. So yeah, so after we allocated 3 integers, we spent a single block of 64 yeah, okay, this is the bucket, not the block. So I'm going to say here I need to say buckets of blocks and buckets of 1 KB blocks and buckets. This is actually going to be nodes of 64 kilobyte blocks. Block is a single block per node, right? So we can copy this and we can put it here, and we can also put it here. Okay, so this is going to be more explicit. So after allocating 3 integers, we used 1 bucket of 64 byte blocks, 0 buckets of 1 and 0 buckets of 64. After allocating 1000 integers, we still have 1 bucket of 64, we have 0 buckets of 1k, and we have 1 node of 64 kilobyte blocks. And when you use 1 single character, we are now, instead of consuming a single an entire 64 kilobyte block like we used to in the previous implementation, now it's going to be slightly less wasteful. We are just going to spend a 64 byte block, right? So it only wastes 63 bytes, right? This is not the use of this pool allocator, but now this pool allocator is a bit more moderate. It supports small allocations, medium-sized allocations, and large allocations, and it kind of tries to fit it in the best way possible. Yeah, so I think that's everything for today, to be honest. We were able to get a little bit a slightly better pool allocator implementation, and I think that's more or less what I want to have for now in my base .age lib. And I think that in the next episode, right, just to keep the motivation, because I've been working on just the basics for 6 episodes. I think in the next episode we can start and try to have basically a client or something that resembles a client, probably with a window and Raylib and stuff like that. Either that, or I'm going to start implementing the server, one of those two. So that's everything for now, and thank you for watching.